Now we introduce the concept of a monomial. A monomial is a combination of numbers and variables put together with multiplication only. And when we want to write this in the simplest possible form, we'll combine all of the numerical factors into a single number called the coefficient. And if we have the same variable multiplied several times, we'll represent that multiplication with a single positive integer exponent. We can talk about what's called the degree of a monomial, which is just the total number of variable factors, or in other words, the sum of all the exponents. So let's see a couple of examples of expressions that may or may not be monomials. So if they are monomials, we'll combine everything so that it's in its simplest form. If they're not monomials, we'll say why they're not monomials. So in this expression, we have 3 multiplied by x multiplied by 5 multiplied by x multiplied by y multiplied by -6 multiplied by y multiplied by y. So we have numbers and variables put together with only multiplication. This is a monomial. Its simplest form? Well, let's use the associative and commutative properties to put all of the numbers together. We'll have 3 times 5 times -6. And then we'll put all of the x's together. That's 2 of them. And then we'll put all of the y's together. We'll have 3 of them. Multiplying all the numbers, you can use a calculator for this if you want. We get -90. And then we have 2 copies of x, so we have x squared. We have 3 copies of y to the third. Just as a note, when we have 2 different variables in the same monomial, we tend to write them in alphabetical order. This isn't a rule. You can put them in any order you want. It's useful within the same expression to keep the same order, and just conventionally, so that we'll agree, we tend to put them in alphabetical order. Okay, so that one was a monomial. How about this one? Well, we have the number 2/3 multiplied by x to the third power. That's just 3 copies of x multiplied together. Multiplied by y, multiplied by x, multiplied by y to the 5th power. That's just 5 copies of y multiplied together. So this is a monomial. To put that in its simplest form, well, we only have the one number, so the coefficient is 2/3. And then we have x to the third times just a single x, which we'll write x to the first power, times y. Again, we'll write y to the first power times y to the 5th. So we've got 2/3. And then we'll add the exponents. X to the third times x to the first is x to the 4th. Y to the first times y to the 5th is y to the 6th. We're left with 2/3, x to the 4th, y to the 6th. This next expression is not a monomial. Why? Because we're dividing by x. So monomials can only contain multiplication. They cannot contain division. What about 3 times x to the -4 times y to the third? Well, remember, x to the -4 means 1 over x to the 4th. So this is 3 times 1 over x to the 4th times y to the third, which I think we'll agree we have division by x to the 4th, not a monomial. And finally, we have this expression that just consists of the number 7. Well, we don't have any operations that are not multiplication. We don't have any operations at all. We could, if we really wanted to, write this as like 1 times 7. So we could write something that's equal to it, that has some multiplication in it. Boring multiplication, but multiplication nonetheless. This is a monomial. A single number or a single variable, still a monomial. Now that we can identify a monomial and simplify one, write it in its standard form, let's consider the degree and coefficient of some monomials. So the monomial 4x squared, the number we're multiplying by is 4, so that's the coefficient. The exponent is a 2. There's only one variable factor and it appears twice, so the degree is just 2 because of the x squared. In the monomial negative 5/3, x to the third, y to the fifth, the coefficient, the only number that appears is negative 5/3, so the coefficient is negative 5/3. Here we have two variable factors, 1 to the third power and 1 to the fifth power. And so the degree is 3 plus 5 is 8. Okay, last one. 7.4 times x times y times z times w. The only number we're multiplying by is 7.4, so the coefficient is 7.4. Each of the variables only appears once. That is, each variable, we're just taking the first power. And so the degree is 1 plus 1 plus 1 plus 1. Or we can just count. We have 1, 2, 3, 4 variable factors. And so the degree is 4.